YouTube viewers, it's Crystal here. In this video, I'm going to go over Module 8 of the Alison course Probability and Combinatorics. And basically, what Module 8 covers is independent and dependent events. And so I'm going over the course material in Python. So I'm solving all the questions in Python. So an independent event has replacement, and a dependent event does not have replacement. So the first question is an independent event with replacement. So suppose two cards are drawn from a standard deck of cards with replacement. What is the probability of that both cards are diamonds? So the probability of diamond 1 is 13 over 52 because you've got 13 cards in a suit and 52 cards in a deck, and then the card is going to be replaced. So the probability of diamond 2 is 13 over 52 as well. So the probability of drawing both diamonds is probability of diamond 1 times probability of diamond 2, which is 0.0625. So it's 6.25% probability. So the next question is an independent event with replacement. Suppose an experiment is conducted where a card is drawn from a standard deck of 52 cards and a fair coin is tossed. What is the probability that the outcome will be a king and a heads? So probability of kings is 4 over 52 because there's 4 kings in a deck of cards, and probability of heads is 1 over 2, which is because there's 2 heads or tails, there's 2 faces of a coin. So a probability of king and a probability of heads is probability of kings times probability of heads is 3.84%. So the next question we have is, suppose a family has 4 children. What is the probability that they're either all girls or all boys? So a probability of boy is 1/2 because you have either a boy or a girl, and a probability of girl is 1/2. Probability, so there's 4 children. There's 4 children in the family. So probability of all boys is probability of boy to the power of 4. Probability of all girls is probability of girl to the power of 4. So probability of all boys or all girls equals probability of all boys plus probability of all girls. So you'll notice that if it's an and, it's going to be a times symbol, and if it's an or, it's going to be a plus symbol. Okay, so the next question is, a fair die is rolled 2 times. Find the probability that both rolls will give even prime numbers. So the only even prime number is 2, and there's only one even prime number. So the probability, so roll 1 is 1 divided by 6, and roll 2 is 1 divided by 6. So probability that both rows are even prime numbers is row 1 times row 2 is 2.78%. So the next question we have is independent event with replacement. A bottle contains different colored candies. 12 red, 6 green, 8 pink, 4 blue. A candy is chosen from the bottle randomly. After replacement of the candy, a second candy is chosen. What is the probability of choosing 1 red and 1 blue candy? So there's 12 red candies, 6 green candies, 8 pink candies, 4 blue candies, and it gives you a total of, I think it's 30. Probability of red is 12 divided by 30. Probability of blue is 4 divided by 30. Probability of red and blue is probability of red times probability of blue. It gives you a 5.3%. So now we have another independent event with replacement. And this is it was originally a true or false question. It says 2 cards are chosen from a standard deck of cards with replacement. The probability that both cards are ace is 1 over 52. And so that's false. But we'll go ahead and work through the question. The first ace is 4 over 52. The second ace is 4 over 52. Probability of both aces is ace 1 times ace 2. And it's 0.59%. So now we're going to get into the independent events. And independent events means there's no replacement. Suppose 2 cards are drawn from a standard deck of cards without replacement. What is the probability that both cards are diamonds? So the first diamond, the probability is 13 divided by 52. The second diamond is 12 divided by 51. So because it's without replacement, they don't replace the card. So it's going to be 13 minus 1 and 52 minus 1. Both probability of both diamonds equals diamond 1 plus diamond 2, and it's 5.88%. The next question is a dependent variable without replacement. Small candy-coated chocolates come in 5 colors, being brown, red, yellow, green, and tan. In an assorted package of 20 candies, the distribution of the colors is as follows. Brown is 8, red is 2, yellow is 4, green is 4, tan is 2. If Sally selects one candy at random and then a second without replacement, what is the probability that both candies will be green? So brown equals 8, red equals 2, yellow equals 4, green equals 4, tan equals 2, and then you have a total of 20. So probability of the first green is green divided by total, and the probability of second green is green minus 1 divided by total minus 1. So the probability of both greens is probability of green 1 times probability of green 2. And so that's 3.1578%. So the next question we have is a dependent event without replacement. Suppose 2 cards are drawn from a standard deck without replacement. What is the probability that both cards are clubs or both cards are from a red suit? So the first club card is going to be 13. The probability is going to be 13 divided by 52. The second club card is going to be 12 divided by 51. The first red card is 26 divided by 52. And the second red card is 25 divided by 51. So you have both club cards equals club 1 times club 2. Both red cards equals red 1 times red 2. Both clubs are red equals both club cards plus both probability both red. And it's going to be 30.39%. So the next question we have is dependent events without replacement. So 3 cards are chosen at random from a deck of 52 cards without replacement. Find the probability of choosing a queen, jack, and ace in that order. So queen is 4 over 52 because there's 4 queens in a deck. A jack is 4/51 because there's 4 jacks in a deck and it hasn't been replaced. And then an ace is 4/50 because there's 4 aces in a deck and it hasn't been replaced either. So a probability of queen, jack, ace equals queen times jack times ace, which gives you a really low probability of a 0.048% probability. So it gives you a really low probability that would happen. So we have another question, which is a dependent event without replacement. 2 cards are chosen from a standard deck of cards without replacement. What is the probability that both cards are queens? So you've got queen 1 is going to be 4/52 because there are 4 queens in a deck. You've got queen 2 is 3/51 because you've already taken out 1 queen. So there's 3 remaining queens and you haven't replaced the card, so it's 51. So both probability of both queens is queen 1 times queen 2 is 0.45%. So again, that's a low percentage. So we have another variable dependent event without replacement. A basket contains 3 oranges and 4 apples. A boy chooses one at random and then, without replacing it, chooses another. Find the probability that both the fruits are oranges. So orange 1 is 3 divided by 7, and because it hasn't been replaced, orange 2 is 2 divided by 6. Probability of both oranges is orange 1 times orange 2, and it's 14.28%. So we have the last question, which is a dependent variable without replacement. And it's a true or false question, but we're going to work through it anyway. A bag contains 10 green marbles and 5 yellow marbles. A boy picks a marble at random, and without replacing it, he picks another marble from the bag. The probability that both marbles are green is 3 divided by 7, and we work that out, and we work it out. We find it to be true, but we're going to go ahead and work it out. So green 1 is 10 divided by 15, and it hasn't been replaced. So green 2 is 9 divided by 14. Probability of both greens equals green 1 times green 2 equals 0.428, and that turns out to be 3 divided by 7 because I checked it, so I know it's true. So that's it for these questions on independent and dependent events. So on independent events, there's going to be replacement, and dependent events, there's going to be no replacement. And then so when you ask an and or question, so when it's and, you're going to multiply it, and when it's or, you're going to add it. So those are the things that you need to take away with you with this module in the course. So thank you very much for watching me go over the course material and course probability and combinatorics, module 8. If you like my video, please like and subscribe, and I will be making you another video very soon. It's going to be covering the second work, but it's going to be in Excel this time. So see you soon.